the address of the remote server on /d. Here means that you want a Microsoft CrashDump. And that's all you have to do. So it's a really easy command to do a really complex job. So here is a screenshot of a remote acquisition of a memory dump. So as you can see, I'm really lazy, so I'm using localhost as a server. But still, this is what you can see when you are using WinDD. So as you can see in the right part of the screen, we have some memory statistic regarding the memory usage on the memory size, the physical address size, this kind of stuff. We can also have the hash of the memory dump. It tells us how long time it took to have the memory dump. In the left part, we have the server part, which tells us that we have correctly received the memory dump and how long time it took to receive it. So again, when WinDD is sending the data to the server, it's done from kernel on, so it's really cool. And it's not using the, for instance, in Windows Vista, Microsoft introduced the WinSock, so it's not even using the WinSock. Yeah, so you can also use it locally, of course. So you have the same information I said before regarding the memory statistic. So it's pretty much the same thing, except you are acquiring your memory dump on your local hard drive or USB stick. Dump to bin is another utility from the toolkit. So again, the usage is really easy to understand. You give a file as an input and it will give you the output. So dump to bin will reconstruct the physical address space from a Microsoft CrashDump. It will also give you an hash. It works with both x86 and x64 Microsoft full memory CrashDump. So here is what we see when we are using the dump to bin utility. So as you can see, it's really a basic output because it's only reconstructing the physical address space from the memory dump. Bin to DMP is way more funny because it will convert a copy of a physical address space, or let's say a linear memory dump, that you can retrieve by using, for instance, a software acquisition tool like MDD, or a snapshot of a virtual machine, of a VMware virtual machine, with the vmem files. There is one thing which is really cool. When you are running a virtual machine with VMware, the vmem file is created at the same time. And with bin to DMP, you can still open this file even if the virtual machine is running. So you can convert the live activity, the live physical memory of the virtual machine into a Microsoft CrashDump. So even you don't even have to stop the VMware virtual machine. So it's really useful when we are doing, for instance, malware analysis, or if you want to check some things regarding the behavior of your virtual machine. And again, this one works with x86, so the 32-bit edition of Windows, and also with the x64 edition from Windows XP to Windows 7. So, and as I said, it works with VMware virtual machines also. So, unlike the previous screenshot, here you can see that there is a structure which is modified. In fact, this is the context structure from the KPCR. because if we don't modify the structure, at least, or if we don't check if the structure is correctly filled, when you will try to read the Microsoft crash dump in WinDBG will think that you are in 16-bit mode and you won't be able to use all WinDBG commands. So by doing this, we have a Microsoft crash dump which is at 100% usable by WinDBG. So now we have the interesting utilities regarding the Windows hibernation file, which is mainly used for forensic purpose. So this one will convert the hibernation file directly into a Microsoft crash dump, and it will work with every version of the hibernation file from Windows XP to Windows 7. And you will have Microsoft crash dump. So let's say you have your Windows hibernation file of Windows 7 SP1, which is still a beta. You will still be able to analyze it, which is really a challenge for the forensic scene. So here is what you see when you try to convert an hibernation file into a Microsoft crash dump. So here, I will try to convert the a Windows 7 64-bit hibernation file. So, as you can see, if you remember the flowchart of the hibernation file, there are a lot of compressed block. So it has a lot of entries. So firstly, the tool has to sort every entry. In this case, it's pretty long because it's a really big file. It's like, I think it's a 4 gigabytes hibernation file. So it will take around 30 seconds or so, yeah, 25. Yeah, and it's fixing the KPCR structure to make it at 100% usable by Windows Debugger. So, and again, it's a really big file, so it takes some time. So we will switch back to the slide in the meantime. So again, it provides also an MD5 hash of the generated Microsoft crash dump. And the last one is not exactly the same one. It's still regarding the Windows hibernation file, but this time it will uncompress every compressed block of the file from the memory. So again, it's really easy command to run. It works with every version of Windows, from Windows XP to Windows 7 with both x86 and x64 editions. It's almost done.
I have a question on converting the hyperfill to a RAM dump. I've used volatility to do that before, but I frequently had failure because of a string of...
Can you take the mic, please, because I don't hear anything.
I just had a question about converting the hyperfill to...
DMP?
To the dump file, yeah, or not a crash dump, to a just a RAM dump, a bin file, I guess you call it. I've used volatility to try to do that before, but I frequently have some failures And I did some research into it. I was told it's because they often have this hex 0 string of padding in the beginning. And I was wondering if you are familiar with that, or if you were able to get.
Yeah, sure. Because in fact, in 2008, I published a paper at Blackhat US to explain the structure of the hibernation file. On that, by using this research, that volatility had been able to use the Windows hibernation file. So regarding the first page, when it's filled with null byte, when you use hiber2dmp or hiber2bin, even if the first page is null, it will work. So you don't even have to have a valid Windows hibernation file. So it's a really good question. Let's say a laptop had been used the hibernation feature. So this laptop is resuming the system. So it's rebooting several times, but the user is not using the hibernation feature anymore. The hibernation file will be still present on the disk. On the first page will be filled with null bytes. And if you use the hiber2dmp or hiber2bin utility, you will still be able to convert it. There is also one thing with volatility. Actually, it only works with Windows XP SP2 and Windows XP SP3, if I remember correctly. In this case, as you can see, it's a Windows 7 64-bit edition hibernation file. So yeah, I'm not really stuck by this. But if I use WinDBG, yeah, as you can see, I can still load the Microsoft Crash Dump in WinDBG, and it works perfectly by using the symbols. So it doesn't have the limitation volatility has. So, and as I said, for instance, if there is a Windows 7 SP1, so it's not even a finished release yet, so you can still do the same thing. So instead of rewriting something from scratch, which is not necessarily a good idea if you cannot improve what already exists, I just use something which already exists, which is the Microsoft Crash Dump format. And I use WinDBG, and it does the job correctly. And for people who like to have a command line, there are people like this. In WinDBG, you have a command line, you have a graphical interface, so it's really complete. And as I said, it's maintained by Microsoft for a long time now. So that's fine, that's perfect. That's why the task is called the Bluescreen of diff is dead, because before we had only the BSOD to generate a Microsoft Crash Dump. And with this toolkit, you can generate a Microsoft Crash Dump from any Windows memory image. Did I answer to your question? Okay, perfect. So hiber2bin, let's say you have a Windows XP, SP2, Windows hibernation file. You can uncompress the hibernation file, even if the first page is null. And if you like volatility, you can analyze your linear memory dump with volatility. So